Recently, I have been involved in training models from multimodal to text generation, taking a look at the latest techniques to train the model. Scrolling from Twitter to YouTube, I was shocked to see another major change in the world of AI. This is because the open source multimodal next generation infrastructure model, large scale conceptual model, was announced at Meta's. You may be familiar with the popular large language models such as ChatGPT. Their core mechanism is to predict the next word. But Meta has gone big this time. Their new model, large concept model, does not even look at the token, but directly understands the meaning of the sentence. Say goodbye to word by word and welcome overall grasp. Imagine that when we understand a sentence, do we understand its meaning directly rather than breaking it down into individual words first? The large concept model is like this. It no longer analyzes word by word like the large language model, but encodes the entire sentence or paragraph into a high-dimensional vector, which Meta calls a concept. Simply put, the large concept model is a new type of AI that can create sentences and understand various things in a slightly different way than previous AI. The C in LCM stands for concept, a model with a concept. By the end of this video, you will understand what LCM is, the difference between traditional LLM and large concept model, what makes LCM unique, how the large concept model works, and how to use the large concept model to create the architecture model. The large concept model is a new language model architecture proposed by Meta AI. It aims to imitate the way humans think, starting from macro concepts and then gradually filling in details. LCM treats each sentence as a concept and performs reasoning and generation at the sentence level instead of operating at the token level. In LCM, a concept usually corresponds to a complete sentence. It is a high-level semantic representation that is independent of the specific language and modality. When looking at traditional LLM and LCM, the way they handle understanding and memory is quite different. Traditional LLM, such as GPT, imagine you are reading a book, but your brain can only remember a few words at a time. To understand the following content, you have to review the previous words frequently. If the book is too long, your memory will be overloaded, resulting in biased understanding or missing information. This is the dilemma of LLM when dealing with long text. Their attention window is limited and they cannot effectively remember and process too long context. In contrast, large concept model, for example, imagine that your brain can directly understand an entire sentence or paragraph as a complete meaning unit, just like giving each sentence or paragraph a label or a summary. When you read the book, you no longer need to remember every word but remember each meaning unit. In this way, even if the book is long, you only need to remember relatively few meaning units. The memory burden is greatly reduced, and the understanding will be more coherent and accurate. So why is LCM so unique? It's because it is similar to the process of human thought. When we write, we first decide on an overall theme, like what should I write about today? And then think about the specific content, right? LCM is similar in that it first grasps the big concept and then creates detailed sentences. LCM offers several impressive features. It supports 200 languages through a special tool called Sonar. Sentences written in Spanish and English can be treated as concepts in the same way, and you can create various AIs without worrying about language barriers. It excels at generating long sentences, avoiding the common issues of sounding strange or repetitive by maintaining coherence and overall structure, and it provides a zero-shot understanding of unknown languages, allowing it to potentially comprehend languages it hasn't been trained on, as long as Sonar supports them without requiring additional training. Definitely stay tuned throughout the end of this video. If you guys haven't followed me, I highly recommend that you do so you can stay up to date with the latest AI news. Lastly, make sure you guys subscribe, turn the notification bell, like this video, and check out previous videos because there is a lot of content that you will definitely benefit from. So that thought, let's get right back into the video. So how LCM works. LCM's architecture focuses on conceptual language processing rather than traditional token-based methods, consisting of three key components: the concept encoder, which converts words or phrases into abstract concepts, creating high-level linguistic representations beyond surface-level text, the large concept model. At the heart of the system, this component processes and understands concepts independently of specific sequences of words or tokens, focusing on the relationships and meaning behind the text, and the concept decoder, which translates abstract concepts back into clear, coherent, and meaningful human-readable language. By dividing language processing into these different stages, LCM prioritizes the underlying meaning of a text over its surface structure. This results in output that is not only more accurate, but also more consistent with the context and intent of the input. While trying to understand the concept of coding the LCM approach, I came across Richard's channel. All the credit goes to him, and I thank him for making the code open source. Please note that I did not write a single line of the code. I am only here to explain it and give my feedback. Before we jump into the code, I would like to show the base large concept model. The core is a standard decoder-only transformer surrounded by a pernet and postnet. Basically, he creates a prenet class to normalize the input embeddings before they are processed by the main model. It transforms the input sonar embeddings into a format suitable for the model's hidden dimensions. This normalization helps stabilize the training process and improve the model's performance by ensuring that the input data is appropriately scaled. He goes on to create postnet to denormalize the output embeddings generated by the model. After the transformer decoder processes the normalized inputs, the postnet converts the output back into a format that can be interpreted as sonar embeddings. This step is crucial for translating the model's internal representations back into a usable form such as subwords or sentences. Next, he develops transformer decoder to transduce a sequence of preceding concepts or sentence embeddings into a sequence of future concepts. It is a key component of the LCM, enabling it to generate coherent and contextually relevant outputs based on the input sequence. The transformer architecture is known for its ability to handle long-range dependencies in data, making it suitable for generative tasks. Finally, he works on creating the base large concept model function to operate entirely in the sonar embedding space. Both the input and output are continuous numerical vectors with the same dimensionality. This consistency ensures the model can seamlessly integrate with other components of a pipeline that uses sonar embeddings. The test confirms that the model processes the inputs correctly, preserving the batch size and sequence structure while applying its transformations. This architecture is likely designed for tasks where the input and output remain in a shared semantic embedding space, such as sentence encoding or intermediate processing. Guys, he made more examples with different approaches. I don't want to take all his code and explain it here. Instead, I encourage you to visit his channel and check it out. We're here to help each other and spread useful content, so feel free to explore it. I'm just here to explain the concept of LCM, share my learning journey, and show you what I've found. Meta's LCM paper has undoubtedly opened a new door for the field of NLP. It indicates that we are moving from understanding words to a higher level of understanding meaning. Although it is still in the early stages of research, the potential of LCM is huge. It is expected to completely change the way we interact with machines and bring unlimited possibilities for the future development of artificial intelligence. Let us wait and see how this concept-driven NLP revolution will reshape our world.